cover today. Okay. Good morning. So I just want to have this reminder before we start today. For the lesson three Zyvox assignments deadline is due tomorrow. So the assignment is due tomorrow, and you have your first check-in, like check-in for Monday morning. So I'm expecting you to submit your assignments on Zyvox, and you use the check-in for to ensure that all your grades are corresponding. What you have on Zyvox and is the same with what you have on your Canvas page. If you have any questions, please do let me know. So that will help with that. Let's move to the topic of the day. Then we have more people to join the class. However, I cannot spare some minutes today. We have so like many concepts to discuss today. So lesson four. Good. We're moving to lesson four, branches, strings, and characters. So this is more from the we're moving to branching statements. Anybody who can just give a simple description of what they understand as branching statement. What do you understand when they say branching statements? What's your understanding on that concept? Anybody willing to share? Please use the chat, or you can unmute yourself. What in the world is branching statements? Anybody willing to share what they understand as branching statements? Okay, if nobody's willing to go, then let's continue. So you notice the programs, the codes we've been writing so far has been some kind of linear, just there is no conditional statements. There is no major surprises. We're not saying if this is not the answer, then you do this. So it's just one way, like a very linear kind of code we've been writing since the beginning of this class and talking from lesson two to lesson three. However, in lesson four, we want to add, we are introducing concepts that will be, with some little bit of surprises, you're making your code to have conditional statements. So in this specific lesson, what are we doing? We want to add conditional logics to our programs. So our code, we want to give it some condition that uh, you execute this if this is the right answer, and if not, then you do this. So that's exactly what we want to tell our programs today, and those are the concepts we will be introducing in lesson four. So what are we going to learn generally in lesson four? So we want to be familiar, we familiarize ourselves with the idea of conditional statements, knowing how to create it. We want to know how we can create such statements with multiple, maybe one or two, more than two statements. So it has to be with more um, operations, with more than one operations using conditional statements. Also, another important thing we will learn in this class is the idea of the relational and logical operators, because these are important operators for conditional statements or expression. So if you go to your Canvas page on lesson 4, I'm sorry, you have the cost overview there. And this is going to show us, how like some of the concepts, some of the concepts we will be learning in lesson 4. We also have the lesson notes, so you can read ahead of class and ask questions. I want it to be as much interactive as possible. And if we go back to the model page, you will see the code inspection folder. What is it about this folder? So this is the folder that we will be using for our coding activities, sample code. So this is a folder with sample codes to explain the concepts in lesson 4. Importantly, there may be new concepts outside the textbooks, outside your Zybox. So you can also play around this before the class and, you ask questions if you have any question on that. So that being said, let's move to so we're starting with the part 1 for the lecture notes. Part 1. So I think we have about 6 lecture notes for this specific lesson, and we'll be starting with the first lecture note. However, I need to emphasize this. Lesson 4 is we have many concepts. I will put it that way. We have many concepts to learn in this lesson. So it is very, very important you plan and manage your time well in times of your, reading your textbooks, submitting your Zybox assignments, because we have many concepts we're going to introduce in this lesson. So what do you understand? I think in our lesson 3, we discussed primitive data types, the different data types that we use in Java. And we said one of those data types is the Boolean, the Boolean data type. And if we can remember some of the things we discussed in lesson 3, was that Boolean data type has just two variable types, in terms of it has to either true or false, kind of. So two values, and they're either true or false. And we said these values are also reserved words. So these are words that the compiler, the program understand its meaning. So you cannot name your variable true, or you cannot name your variable false, because these are reserved keywords known to Java. So any question on the Boolean data type, or any questions on lesson 3 before we move directly into the topic of today's class? Thumbs up if there's no questions. I am confident. And we can move to the next. Oh, thank you very much. That's beautiful. Okay, so we have been saying Boolean Boolean statement. I think when I was given the description of what we'll be learning in this lesson. So Boolean statement evaluates if a statement is right or is true or false. I wouldn't say right, it's true or false. And the expression itself consists, the expression consists, I would say it consists of more than one statement, more than one Boolean statement. So an expression consists of Boolean values and logical operators that evaluate to true or false. So this is a statement that is usually more than one. It could be two or more logical statements that may be true or false. That's the definition. So it's more than one statement. The expression is more than one statement. And just look at the example we have here. System.out.prints in new line, not. So we will discuss this operator. So you can see from the first parenthesis, this is a statement. And when we have the ampersand, the double ampersand sign, and after the double ampersand sign, we also have another statement. So expression consists of more than one, more than one Boolean values. So it's more than one statement. So we have two statements, for instance, in the system.out.print. The first example we have in our lesson notes. And it's similar to the other example we have. So it has to be comparing, it has to be comparing between two or more things, which is just that simple description. You're comparing. So it has to be more than one statement. You're comparing between the statement and the statement which is correct, which is right, which of the statement is false, which of the statements is right, which of the statement is true, or which of the statements is false. Thumbs up if you understood the description of what a Boolean expression is. It's always more than, just more than one statement. Only have you understood this concept? Oh, thank you. And let's move to another important operators. When we started this class, I was saying we need some relational, some logical operators. So what are these operators? And the first one we will use that is very, very important when we're talking about writing a Boolean statement or a Boolean expression is the relational operators. It is also called the comparison operators. This is when you're comparing, these are operators we use to, you're relating, you're equivalent, is this equivalent to this? Can you compare statement A and statement B together? And in Java, these are the different symbols, we write this operators, or we describe this operator. We have the greater than, we have the less than, we have the less than or equals to, the greater than or equals to, then we have the equals to. So this is very, very different from when we have the equals to. This is double, double equal sign. And we have the not equal to. So this is the way we write that in Java compared to how we understood it in our normal mathematical symbols. Can anybody describe or explain the difference between the equals and the equals symbols? Can I know? Please unmute yourself, use the chat. I want this class to be as interactive as possible, please. I want to also learn things from you. Anybody willing to go? Do you understand what is the difference between the equals and the equal symbols? They are two different things. And I think we discussed this in lesson 3, that the single equals symbol is the assignment operator. That's when you're assigning, you're initializing a variable to a value. you need assignment operator. Yeah, for instance, you're initializing int apple equals to the equal sign is telling the compiler nums apple is 50. So they're two different things. When we use the two double equal sign. So when we use the two double equal sign, it's more of we are asking the computer, we are asking the program, is statement A equivalent to statement B? Is statement A the same as statement B? They're two different things. Unlike when you're assigning that this variable is equals to this value. Do you understand the difference? Thumbs up if you understand this difference between this double equal sign and the equal symbols. So this one is an assignment operator, and one is to to compare to say is this equivalent? Is this the same thing? Statement A and statement B the same thing? So let's say relational operators, or we call it comparison. Some textbooks call it equality. So that's the same thing. Is this related to this? However, I need to also emphasize this. Relational operators can only be used for numeric or character data type. It is only used for numeric or character data type. And from this example we have in the textbooks, we said radius is equals to 5. So here, when we're talking about the lesser than sign, we say, is 5 lesser than 0? No, so it's false, because 5 is actually greater than 0. Is 5 lesser than or equals to 0? No. Is 5 greater than 0? Yes, because 5 is greater than 0. Is 5 greater than or equal? So this one is greater or equals to 0. Yes, it's true. 5 is what? 5 is greater than 0. Is 5 equivalent to 0? No. And that's where we have, I'm trying to explain the difference between these two signs, the equals, which is the assignment, the single equals, and the double equals to sign. So this is like, is 5 and 0 the same thing? No, 5 and 0 is not the same thing. Is 5 not equals to 0? Yes, 5 is not equals to 0. Also, if you understand how we use the relational database and the relational operator, right? I'm talking about database now. The relational operators. Perfect. So this is more used for numeric and the character database. We cannot use this operator to compare strings value. So you cannot say, for instance, you cannot say is dummy equals loud. This is a string. These are words. They're not the same. It's almost impossible to use that. Is apples equals orange, or is apple greater than orange? No, you have to declare what the value of apple is, what the value of orange is, and say value of apple is 20, value of orange is 10. So is 20 greater than 10? So you have to initialize. You cannot use this. You cannot use this type of operators to compare strings. So let's move. If we understand that, then let's move to the next operators that is very, very important when we are building our Boolean expression is also the logical statement. The logical statement is helps us to build, it helps us to build our Boolean expression. This is not statement now, but the expression itself, because the expression contains more than one statement. So here the logical operators helps us, to build the expression itself, combining two or more Boolean statements together, comparing two or more statements together. And we have four main logical operators here. We have the not, we have the and, we have the or, and we have the exclusive or operators. So let's go. What is the not? What when we say not, it means it is not something. So for instance, we're saying if 5 is not equals to is okay, for instance, let's do this. So when we say P is the actual value, which is the true value, and not has to be the opposite, apple equals to 5. And we use we are assuming here that age is equals to 24, for instance. And we'll say not age. Is age, is it greater than 18 here? Yes or no? Is age greater than 18? Anybody willing to go? Yes, it is greater than 24. I'm sorry, 24 is greater than 18 because age here is greater than 18 and age is 24. So 24 is greater than 18. So when we use the not sign here, we're saying age is not greater than 18. And it's false because truly age is greater than 18. So when the statement is true, when the statement is true itself, then the first sign will be false. The logical operator not will be false. And in this example I just described, let's say the other one, when the statement is false, so it's always the opposite of the statement. That's how the not operator works. So when the statement itself is false, the not operator is always true. So it's always, it takes the opposite true value of the statement. And here we are saying weight, which is 140, equals 150 plus, because 140 is not equals to 150. So the not operator is true because 140 is not equivalent to 150. You understand the not operator, how the not operator works. Thumbs up if you understand how the not operator works in particular. Any question? I'm not seeing any thumbs up, so I think there's a problem here. Okay, my turn. Any other person? Do you have a question? Please interrupt me. It's very, very important we understand this concept. So when the statement is true, the not operator is always false. And when the statement is false, the not operator is always true. Why? Because the not operator takes the opposite true value. So when age 24 is greater than 18, which is true, then the not operator will be what? Would be false. And let's go to the and. And these are the rules are simple and straightforward, but we need to be sure we understand this concept. So please interrupt me, ask questions. This is a very, very important concept. And we must understand the difference. We must know how to use them, how they work, how they operate, how they're being executed. It's very, very important. And we have the and operator. And what is the and? Here, all the statements in the Boolean expression must be true in order for the statements to be evaluated as true. So when statement 1 and statement 2 is false, then the AND operator, the evaluation of the AND operator will be false. When statement 1 is false and statement 2 is true, because it's AND, it means the both statement must be true. The both, this is not all, this is AND. So in AND, all the statements within this Boolean expression must be true. The keyword here is all. All, I mean all the statements. So if we go to this example, for instance, we have age as 24, the weight as 140. And it says age is what? Is less than or equals to 18. Is 24 less than or equals to 18? No. So from this first statement, from the first statement, it is false. And we will discuss what happens. How does the computer operate when the first statement is, how does the compiler understand operate when the first statement is false and we're using an AND operator? Do the compiler has to go through the order, it has to go through the order expression. Do the compiler has to execute the order expression? We will go through that in this same lesson. So one of the statements is already false. So we know the AND operator evaluation will be false because it takes all statements within the expression to be true for the AND operator to be true, to be evaluated as true. So here, the age is greater than 18 because 24 is actually greater than 18. And the weight is greater or equals because the weight is actually equals to 140. So the both statement here are true. And until the both statement is true, the AND operator would not evaluate the statement as true. Any question on the AND operator? Thumbs up if you understand that's how this operator works. Thank you. And the next statement, operator, we need to also understand here is the or, and this is always denoted by double bar. And what is the or? What does the or statement say? Here, at least one of the statements must be true for the all operator to be executed as true. The keyword here is at least one. So when the both statements are false, of course, the result will be false. When the first statement is false, however, the second statement is true, then we have a true result. When the first statement is true and the second statement is false, we also have a true, true result. Why? Because it only takes one of the statements to be true, one of the operand to be true. I think that's what operand, yeah, statement, just for you to understand. It takes just one has to be true for the all operator to be executed as true. Any question? I guess no. So let's look at the example. We have age is 24. Is 24 greater than 24? No, 24 is not greater than 24. So the first statement is false. However, the compiler will not stop there because it's an or statement. It will check. It's an or operator rather. So what is it going to check? It's going to check the second operand. Oh, then if the first one is wrong, let me check the second one. Maybe it's correct. Maybe it's true. And it said, wait, greater than or greater than or equals to 150. I mean, less than or equals to 150. And he said, no, it is not. It is not greater than or equals to. Weight is actually less than 150. Is and is our age greater than 34? No, the age is not greater than 34. However, the compiler doesn't stop there. It checks the other statement and it says, weight, okay, weight is less than or equals to 140. So the statement, this expression should be executed as true because one of the statements is actually correct, is actually true. Any question on all operator? Thumbs up if there's no question, and we can move to the exclusive operator. Thank you. So, what is the exclusive operator? That's the exclusive or. Yeah, it's a little bit, it's a little bit different from the whole, just a little bit different. But it's very, very important we understand the difference. Yeah, it says one of the statements, exactly one of the statements. The other one was at least one. Here it's saying exactly one of the statements must be true in order for the expression to be true. Otherwise, the expression is false. So let's say if statement A is false and statement B is false, then of course we have false. The expression will be false. If statement A is false, however statement B is true, then because exactly one has to be true. Exactly one must be true. Just one. So here, if the both statements are true, it will be false because it's saying exactly just one must be true. It's different from at least. And here, let's look at an example here. So it said age, and our age is still 24, greater than 34. No, 24 is not greater than 34. Our weight is 140. 140 is not greater than 140. So because the both statement is false, then our exclusive operator executes this expression as what? It's not. So it's executed as true. and it's executed as false. I'm sorry, as false. And here we have 24. Is 24 greater than 34? No. However, the weight is greater or equals to, because the weight is actually 140. So the statement, one of it, at least one of it, exactly one of it is true, not the two. The second statement is true. So exactly one is true. And the exclusive whole takes execute this expression as true because exactly one is true. Any question on these operators and how they operate, how they work? Any question? Thumbs up if there's no question. So I know we are. Okay, thank you. So now we've discussed the different operators from the relational operators to the logical operators that helps in building our Boolean expression. However, I was saying it. What happens when the whole, at least one is already met? What that's and that's one of that's one of the difference when we have the inclusive all and the exclusive all operator. When we have the all and the exclusive all operators, we have something we call the short circuit evaluation. So what happens in the short circuit evaluation? So the short circuit evaluation actually allows the compiler, the computer, to quickly evaluate the Boolean expression. And here, evaluation of the logical expression is always from left to right. The order is always from left to right. And I was explaining that in the or statement, once at least, we said at least one of the statements must be true. So, for instance, if in the statement, for instance, one's age is less than or equals to 14, at least one is true. Do the computer has to go through, do the compiler has to go through the other statements? And that's one of the purpose of this short circuit evaluation. Here, the compiler, here, what happens? How does the short circuit occurs? Once this true statement is made, then the compiler just executes because you don't have to check. At least one has to be true. And the first statement is true already. And it's the same thing for hand. Once the first statement is false, the compiler don't have to check others because it takes all statements, the bold statements, or perhaps it's more than one, it's more than two rather. It takes all the statements within that expression to be true for the compiler to run the AND operator as true. So if the first statement is false, the compiler has to go through the other statements? I guess not. And that's why we have this concept of the short circuit evaluation, which helps, the idea is to allow the compiler to quickly evaluate a Boolean expression. Once and it only works in the not and all operators. Can anybody explain why this does not work in the exclusive all expression? Can anyone explain this? Anybody willing to share? Unmute yourself. Why? Why do you think The short circuit evaluation does not or cannot work for the exclusive OR operator. One thing we understand is you remember the exclusive OR say exactly one. Requires more calculation, yeah. It has to check because if it says exactly one. So if the first one is false, then the compiler needs to check the second one because exactly one of it must be true. So if the first one is wrong, it still doesn't tell the compiler the whole expression. If the first one is false, it doesn't tell the compiler the whole expression is false. No, the compiler still needs to check the other, the other statements within the expression. So the short circuit evaluation actually helps the computer to speed up and save time. It's speed up and save time when executing a Boolean expression. And we will see some examples here. So in this example, for instance, please interrupt me if you have any question. This is very, very important. In this example, for instance, we have our age and height variables. And age is 25, our height is 70. And here is our Boolean, our Boolean expression. That is age, which is 25. Is it greater than 50? And the compiler says, oh, this is an AND. This is an AND operator. Comparing this statement and this statement, and the first statement is already wrong. No, I need to stop here. Because the first statement is false already. So there's no point. There's no point wasting my time, to execute the second to execute the second statement. Because both of the statements must be true for the AND operator to be executed as true. So I just save my time. So here, it stops at the first, evaluating the first statement. Once the first statement is false, the compiler doesn't have to waste more time. You say, what? It takes all statements within an AND operator to be true for the expression to be true. So I just leave it here. So let's go through the second example, which is an OR statement. And we said height 70 greater than 60. 70 is greater than 60. And you remember, in the OR operator, the rule is at least one. So the first one is true. So why should I bother myself to check the second one? Because it says at least one. So the compiler stops here. Once the compiler meets a true statement, the compiler stops. I don't need to check other statement because at least one must be true. And this one is true already. So why should I go on? And this is also an example of the AND statement. And it's the age is 25, weight is 145. 145 is less than 180. It's true. So the compiler proceeds to the next one because this is true. However, if the first statement is false, the compiler stops there because it's an AND statement. So it's an AND statement and the first statement is true. Oh, let's say it's the second statement true. 25. Oh, 25 is greater than or equals to 20. Yes, 25 is greater than 20. So the compiler runs entirely all the statements because the both statement is true, then there's the expression, the execution of the expression itself is true because it takes all the statements in using an AND operator to be true for the execution of the statement itself to be of the expression itself to be true. And let's see, in the or statement, weight is 70. 70 is where is greater than 60. So this is true. Oh, this is not. I'm sorry. This is not. 70 is greater than 60. And the expression said not. So 70 should not be greater than 60. However, because this is an or statement, despite the fact the first statement is false, it goes to the next statement because at least one. So since the first statement is false, but at least one has to be true. So it goes to the second statement, which is 25. 25 greater than 50? Really? Is 25 greater than 50? No. So here the both statement is false. And a question. Thumbs up if you understand the concept of the short circuit, how the compiler, stops once the condition is met, one specific condition is met with that operator. It's an AND operator and all statement is true. So the compiler doesn't waste their time. Oh, I don't have to waste my time. It's an all operator here, and one of the statements is already true. Then it's fine. I'll just save my time and my energy perhaps on the next statement or the next command, the next set of instructions. That's what the compiler tells us when we're executing a Boolean expression. However, we have been discussing the order of operation, the order of operation. And in Boolean expression, there is also order of operation. How does the compiler execute? Of course, our parentheses, that's the highest order. Very important. Very, very important. So it executes whatever we have within the parentheses first. It's execute, it checks is the weight actually less than 180? True. So that's the first order. And we talk about the post. We already talked about the post increment and the pre-increment. Post increment and the pre-increment or decrement, whatever you want to use. That's the next order. And we talk about how, of course, our numeric operators itself, the multiplication, divisions, and modulus. Then rather than the operator now said, oh, the compiler now said, oh, we have to also talk the addition and the addition and the subtraction numeric operators as well. And after the compiler execute the relational. So we've been discussing that relational operators. And here we see relational operators is majorly used at the statement level comparison. When we're comparing, oh, is this variable and this value the same? Is this variable and this value equivalent? How can we, is this greater than or less than? Is this equals to the value? It could be between two variables. We could say is age greater than height, for instance, is height greater than whatever. So after the relational operators, then the last, which is the lowest precedent, is the logical operators, which is combining, at the statement level, then when this is comparing between two or more statements, So between the statement and the statements, and that is the order in which a Boolean operation executes. Any question? Any question? Thumbs up if there's no question. Thank you. And I said in our model page that we have the code inspection. So I want us to use the last the last few minutes of this class and the next 25 minutes. Let's go through the code inspection folder, and we will be working on code source 2, which is the leap year, the Java. So I want you to open your IDEs, open your IDEs. You can copy, all you have to do is to copy this code and paste it. Copy and paste. Because we are not writing fresh code, but we will be discussing the structure of the code or the structure of the program. So thumbs up if you have your IDEs and you already copied the code so we can follow through. We have a few minutes to end the class. Thumbs up if you have your IDEs opened and you have copied the code. What the source code we are working with is the source code 2, the leap year. Thank you. The leap year. Thumbs up if you have your IDEs and you copy the code. Code is pasted on your IDE. Thank you. So, of course, the first line, we all understand the importance of the scanner class. And this is because we need to where can I find the code? It's actually on your model pair. If you go to your Canvas page and you go to the models, and on that you have lesson 4, and you go to the code inspection folder. Code inspection folder, and we are working on source code 2, the leap year program. Found it. Good. So, like I said, the first line of code is to what? Is to import the class called the scanner class. And we have in our lesson 2, lesson 3, we have used this class, and we will, until the end of this class, until the end of this course itself, we have to use the scanner class, which helps us to get values from the user. And we have our class, which is the leap year, and we have our main method, because for now we're still writing within the main method. And we had to create a scanner objects that will hold, that will request and hold the value, the user's input, the user generated input. So we're naming the scanner, we're naming my scanner the abbreviation for scanner, but now we're naming the specific scanner as input. That's the name. This is user generated. You're the one giving the specific name. You can name it anything you like. And you're calling the scanner method, which tells, it tells the compiler this information is coming from the keyboard. The user is to put this value in the keyboard. And we're prompting our users to put a year, a specific year. So we're telling, enter a year. We want to see if it's a leap year or not. So this is the statement is prompting the user to provide the information. So what happens? Where is this information going to save? Where is this information going to store in memory? So we need to declare a variable and initialize a variable to the scanner objects that has been created. So the variable is an integer, because here is an integer, is an whole number that doesn't have a decimal point. So what is the variable name? Year. And we're telling this variable, the text the value, the statement itself takes the value the user inputs and store it in the in the year container. So we're saying store this value, any value the user input in the year container. And here, this is our Boolean statement itself. And the Boolean statement is checking. What is it doing? It's checking if the year the user entered the year, or the value the user has given us in terms of the year is a leap year or not. And we need to declare, of course, we need to declare our Boolean data type, because that is going to tell the compiler how to save, how to store the data in memory. And it tells the compiler the Boolean expression, this Boolean declaration data type is already telling the compiler you had to save the result from this expression. You had to store the result from this expression as either true or false. And what does this expression say? And you can see we have two statements here. The first statement in the first parenthesis, that's the first parameter, and we have a second operand, which is in another parenthesis. So how does we discussed in the last slide that the order of operation, how does the Boolean expression works? And we said the order is always from the left to the right, the execution. So what the computer does is that, oh, I need to calculate this. So what happens if I'm calculating this? And it tells, it tells the compiler, year is if the year the users has entered, if is divisible by 4 and is equivalent. So when this year, I don't know what year the user is going to enter, I'm just saying, I'm just telling the compiler to check when the year the user, if the year the user entered is divisible by 4 and is equivalent to 0, the answer is 0. And the year is divisible by 100 and not equals, we're saying it is not equals to 0. When it is divisible by 4 and it's equals, it's equivalent to 0. And, this is an and statement. It means the both statements, the both statements within this expression must be true, because this is an and. Here, the both statement must be true. For this, so it means the year is divisible by 4 and the year is divisible by 100 must both be true for this entire statement to be true. Do you understand this? And the other statement is now saying, oh, however, because 4 is generally the statement, so it waits and say, let me see what is happening in the second parenthesis. Let me see the execution of the second parenthesis. The year the user entered is also divisible, if it's divisible by 400 and is equivalent to 0. So it takes the result here and the result here and compare. So it's either one of the result here is true, at least one of the results, either the result, the entire, don't forget the and here. And here made it more complex that this statement has to be true. So if this statement is true, or at least one of the statements has to be true for the year to be a leap year. Then the last thing here is, we say display the results in a message box. So we're displaying the result here. And it said year, so this is like whatever year the user entered after this expression has been made. So it checks if this year is a leap year or not. Any question? Do you understand? Can you interpret this code? Can you solve this problem? It's very, very important you learn to, how do you interpret? Okay. How do you interpret? Because your exams is going to check your understanding, your knowledge in how you can interpret, how you can it takes you to act, you're acting as a compiler. How does the compiler works? That's what um we're checking here. And these are the kind of questions you should expect in your exam. So it's very, very important. So let's run it and see. So we're in 2026 and my code is my computer is a bit slow. Okay, let's enter a year and 2026, for instance, which is the year. Oh, 2026 is 2026 a leap year and it's false. So you can check other years. Let's see. You can put other years to see if it's a leap year or not. So what I want you to understand is that how these operators actually works. So it's like this two must execute to ensure that, oh, is this true? So one of these operator has to be true. One of these statements are, sorry, has to be true because it's what? It's whole. It's an all operator. So any question? Thumbs up if there's no question. I haven't seen any thumbs up. Okay, Abby. Only Abby? Okay, thanks. Any other matter? Okay, thank you. At least I have. If you have a question, if you need, just please interrupt me. Send me a message on Canvas. You can also attend the virtual office hour if you have any question at all. So that being said, I think that will be all I have. Yeah, all I have for today. However, I want to also um our exam is in less than a month, the first exam, which is going to test your understanding, your knowledge on lesson 2 to lesson 4. And I have been receiving questions on how the exams look like, what the exams is. Are we gonna write code? No, we're not writing code. Yeah, you don't need your IntelliJ for the exams or your IDEs, any of the IDEs you're using. However, it is very, very important you understand how to interpret result output. How I want you to put yourself, like I said, in the position of a compiler. How does the compiler operate? What is the order of precedence for this operation? What is, we want to test your understanding on basic concept, on the concept you have learned, not for you to just write thousands lines of code in your exam. No, we want to ensure you understand the concept, we have discussed in this class, which is very, very important. However, towards the exam, we will discuss more. And we also have, there is a study guide here. which will tell you uh, the different concepts you discuss in this class. When you know, and of course, it's a true or false kind of options, and it's multiple choice questions. Um, Also, your Canvas quiz, which is your lesson quiz, I will advise you take it towards your exams, maybe start working on them towards the end of the month for lesson 2 to lesson 4. So this is a way to prepare yourself. This is a way to prepare yourself for the exams. And also you can take this test on limited time because the purpose here is for you to really understand this concept. The purpose is for you to really understand this concept. So you have the opportunity to take it on limited time to familiarize yourself, get familiar with this concept. And if you have any question on any of the concept, either from lesson 2, from lesson 3, and also in lesson 4, please do let me know. Do let me know. Send me in a message in Congress. Um, Come to the virtual office hour if that is convenient for you. Just ask questions. I want you to ask questions because I want you to be successful in this course. I want the best for everybody in this class, and I want you to not just pass the exam, but I want this concepts, this language to be useful for you in the future, to also build up on the other concept outside this class as well. So that'll be all for today. Let me know if you have any question. Have a wonderful weekend, and I'll see you on Tuesday.
Thank you.
You're welcome.
Thank you.
Welcome.